Hello and welcome. Give me a thumbs up if you can hear, just to make sure audio is working. All right, okay, because several times I've spoken for a while and then discovered no one can hear me. And those are probably the most insightful things I said was when no one could hear me. Okay, so the Slido poll. It should show up in the app. I will paste a link to it here in case you can't get to it from the app. It should, let's see, how do you get to it? There should be like a show apps button in the bottom right-hand corner that you can bring it up. Let's see. I want to see what everybody's here for today. So we're going to be talking about how different ways of learning programming. And it looks like a lot of us are here because I work with developers and want to understand what they're doing, which makes sense, right? Or you're a developer, you want to increase your skill. You're looking for ways to help teens or kids learn programming or something else. We've got 0% of the people here are looking at shifting career. Oh, okay. Now we've got some people looking at shifting career. So hopefully we'll give you some ideas here on what that might look like and some ways to kind of head toward those types of things. So first of all, I wanted to answer a few questions here. So what is computer science? Because there's a lot of these terms and they mean slightly different things. So computer science is the study of what can be computed. It's a branch of mathematics. It may use computers, but that's usually kind of incidental to the fact that you're to what you're studying. So if you think of it, well, I'll talk about that in a minute, but it's very much the theory behind things. So and now this gets convoluted sometimes. I've seen some junior colleges that use computer science to describe the fact that people are learning how to use Microsoft Word. But generally, if you're at a university or something like that, and you're taking a computer science program, it's probably going to be focused on the branch of mathematics that has to do with what can be computed. Likely, you'll be learning some computer languages and stuff like that, but it's going to be more in a language agnostic way. Programming, on the other hand, is creating instructions to get a computer to do useful things. Now, as you can imagine, that has some overlap, a lot of overlap with computer science, but it's really focused more on the practical application of it. One way to think of this is if computer science is like learning physics, programming is more like learning engineering or how to do a particular thing with the physics. It's more focused on specific programming language, oftentimes. There's some overlap with computer science. It's less focused on math than what you'd have in computer science. You're probably going to spend less time thinking about, spending a lot of time on the theoretical aspects of algorithms and stuff. With programming, it's more of how do I get the algorithm to do what the customer is asking for. So if we look at learning computer science, you're going to be looking at things like discrete mathematics, theory of computation, algorithms, and data structures. And if you look at learning programming, you're going to be looking at probably learning a few programming languages. So you've got if you go work somewhere, you've got some experience in that particular programming language. You're also going to be, if you want to get good at it, you're going to be writing lots and lots of programs, just like speaking a natural language. You're going to be needing to develop lots of skill just in, I've done this many, many times, I can find a way to do this. Problem decomposition, although not taught directly, is often a very, very big piece of learning to program, of figuring out how do I take what the customer is asking for and break it down into smaller sections that I can actually get the computer to do. Next week, we're going to be talking about breaking stories down into smaller sizes. There is a very analogous relationship between breaking a story down into something small that's deliverable and what a programmer will do in trying to break down whatever they're trying to deliver into something that they can reason about and code one piece and then move to the next piece. Give me just a second here. Mute everyone just to make sure nothing unexpected happens. There's some overlap with the practical parts of computer science, but it's the focus is very, very different if you're trying to learn programming. Now, as you can imagine, there actually is a spectrum here, right? There are some programs that are computer science, and was it Dijkstra, I think, that was like, yeah, don't give anybody a computer for many, many years or else you'll ruin them. When he was teaching computer science stuff. Then there's the other side of things of like, let's just get people programming so they can go out and get a job and all the stuff in between. The program I did on my master's degree was kind of a nice balance between the two. We had a lot of theoretical classes, but we also had, hey, we're going to learn how to use this programming language and do this type of thing and this type of thing, and which worked out really well for what I was needing. So one way to kind of think about these two things is if so on the, let's see, the left hand side here, we've got a band just sitting around playing. These people are just sitting around jamming. They could become awesome musicians and make wonderful, wonderful music doing exactly what they're doing. They get together every day and just play and play and play. On the other hand, on the right, this is just a picture I took of my old music theory, I think it's music theory 3 or 4 textbook, and something that I was marking up in that textbook. Okay, that's a very different approach to learning music. It's very, very valuable, but if you want to really understand why things work that the musician's just sitting on and playing, you're going to have to do that type of study of things. And this is kind of similar to the idea of the programming. We get stuff done. We've done this enough. We can make it work. Is the band practicing in the garage and they get really, really good. The computer science is more of the, we're going to learn all the theoretical things. It's very possible to learn all the theoretical things and still not be anyone, and still not have any skills that people would want to pay to come listen to. So anyway, I think that's one way to kind of think about those two things. Ideally, you want both, right? Somebody that is a very, very good musician, can write music, play music that people like to listen to, and understands exactly what's going on. My master's degree in music, it was interesting how much time we spent discussing the Beatles music and why what they were doing worked in different places, which was not at all what I was expecting. I mean, we spent a lot of time on other things too. I think it's just my music composition teacher just happened to be fascinated with the Beatles at the time. Okay, so in your experience here, which is most true? So one needs a college degree to be a software developer. A college degree is not particularly important for a developer. A college degree is only useful for getting interviews, or a college degree is negatively correlated with developer skills. So which one of these ones sticks out? So it looks like most of us are kind of in the camp that college degree is not particularly important for a developer, and then followed by, but it is kind of good for getting interviews. And that's kind of where I was expecting. Actually, I did not expect it to be quite as heavy on saying college degree is not particularly important for a developer. That may speak to how big of a gap there is between teaching people how to program and teaching them how to do useful things. I've seen a lot of, and we're going to look at some resources here in a little bit that were designed by people who are saying, how do we teach people to solve problems with computers? And really looking at the pedagogy aspect of that. Somebody was asking if I'm recording it. Yes, this will be on the, as a matter of fact, it's streaming to the AgileLnL YouTube page right now, and it will be live in a record form as soon as this is over. If you can't find it, just email me back on something. I'll make sure you get it. Okay, so that's kind of how we're feeling about this particular thing. So let's look at some ways to learn to code. So we're going to be looking at how can you learn to write. How can we learn how to tell computers what we want them to do in ways that's valuable to us and the people around us? Well, a college degree is always an option, right? College degrees are often very good for trying to make sure that there's no big holes in what you do. They're very methodical. On the other hand, college degrees are often, the first classes I took in computer science stuff was at a university that later shut down their computer science program. And part of the reason was that I think they had a lot of professors there that had learned what they were doing in the 70s or 80s, and now they were trying to teach it. And what they were teaching wasn't particularly useful to the people. And I mean, there was a guy from NASA and stuff, and I learned a lot from them for what I was looking for, but it wasn't necessarily well aligned with people being able to get jobs after they had graduated. Another great way to learn code is college certificate. There are programs, and we'll look at some of them, where you get a certificate in particular things. And that can be especially useful if you're in a particular area, you've got some technical skills, and you're looking over here and saying, hey, you know what? If I could get a little bit more technical skills in how to manage databases or how to program for these types of web technologies. So college certificates can be one way of doing that. Code boot camps had, several years ago, they were very, very popular. So where you're taking 9 months and going out and just hitting things hard of writing lots and lots of code should be the idea. We'll look at those in just a second. A lot of those have actually moved to universities, which I think was an interesting shift. Programming classes that aren't necessarily associated with the college, or maybe it's the college class without it being toward a degree, and then books. So these are all ways to learn to code. So, question for you: what do you find the easiest to learn? So, is it easier to learn in formal college classes, high quality self paced classes with videos and projects? So, something like edX, Coursera, Udemy, something like that. Formal industry training, or just give me a few books on the topic and time to read them. And Jess is mentioning he knows several excellent developers who didn't go to college, but they wouldn't be able to get hired by a large corporation without a degree. I think that's definitely an issue. I think particularly if they've been working in an area that their stuff isn't easy to see. If one of those developers had worked on, let's say, Google Maps, they might be in a lot better position to be able to go ahead and get a job with something like that. Yeah, I think yes, good point of you learn most by doing. That's why I think the best programs are the ones that actually have you writing lots of code. If you're skipping that part of it, you may know a lot of theoretical things, but you still may not be able to play the piano, even if you know exactly what all the notes are supposed to do. Okay, so most of us are saying high quality self paced classes with video and projects, followed by formal industry training. It's interesting. I find this interesting that the formal in person college classes is lower on the list. And I think that probably speaks to problems in higher education. Some of it's because it's very focused on theoretical stuff. So that makes sense. But I think it's because higher education has some gaps they need to fill. Okay, so let's talk about college options here. You've got undergrad, like you're going for your undergrad degree, something computer science. Graduate degrees, which can be a great way, even if you studied something different. My undergrad and graduate degree are music composition, and then I got a degree in computer science or IT and computer science things as a graduate degree. And the only requirement is you're able to pass our kind of introductory courses and you have a bachelor's degree in something, anything. If you prove you make a bachelor's degree and pass these first 3 courses, you ought to be good. And that was actually through Harvard's extension school. So, which I found to be a great program. Certificates, which are more, oftentimes they can be stepping stones toward a graduate degree, but there may be 4 to 6 classes around a particular topic. They can also be very useful if you've already got a degree and you're just trying to say, hey, I want to up my experience in a formal way around this particular topic. Micro certificates are another thing, which oftentimes are taught by college professors, but not necessarily giving you college credit towards something. And sometimes they can be a really good mix for people. And sometimes they do give college credit, but it's a much smaller thing. And the micro certificates, like Harvard Extension School has micro certificates, and it's usually like you take 2 classes on a particular topic. Nice thing is, it's something you put on your resume. It shows that you're doing continual education. Boot camps. So one thing I want to mention is on the boot camps thing, where it's maybe like 9 months of really intensive. A lot of those have moved to, or a lot of colleges and universities have started to offer those. The people I've talked to that have done those have been very, very happy with them. There's also been a lot of for-profit organizations doing that. And some of those are kind of tied, some of those are even, they're very selective who they take, and they don't even charge you anything, but they get a percentage of your salary afterwards for a certain amount of time. The advantage of that type of thing is they are very, very focused on trying to get you the highest paying job they possibly can as soon as you finish. So depending on what the market's like, that could be really good if they've got contacts that you couldn't get for yourself. There's also some nonprofit boot camps built around trying to get people skilled up to enter the industry. Usually it's a shorter time frame, so maybe 12 to 26 weeks. Some I've seen that were 9 months. And they often are very focused on trying to get you into that very first programming job. So they're trying to teach you, at least the ones I've seen, are very focused on trying to teach you just enough that you can get your foot in the door and start coding every day. And then you'll learn the other things you need to learn from on-the-job training, which isn't, as a model for when it works well, that's actually a great way to do it, right? You've spent half a year focusing on getting just enough experience to get your foot in the door, and then you learn as you're getting paid for stuff and continue to grow in that, which is a great model when it works right. Online learning platforms. So we have things like Coursera, edX, Udemy, LinkedIn. There's all these different learning platforms of various quality, depending on, a lot of it depends on the quality of the people that are making the courses. Coursera, I think, is just coming from colleges. So oftentimes, those you've got actual college professors teaching them, which can mean they're really high quality. It sometimes can mean that they're not as high quality because the professor's used to being in front of an audience and speaking, and the audience has to be there, and maybe they're not as good at making it for online. There's some, and we'll look at some in a minute. That are very very good that I'll point out. Okay, so what do I recommend? So I want to just point you to some things that I found very, very useful. I'm sure there's lots of other things, but I'm trying to point out things that I've actually experienced or been close enough to that I know they're very good, that I've been very impressed with them. So the first thing I want to mention, as far as formal education, Harvard Extension School is very, very worth looking into if you're looking for either getting a graduate degree, a certificate. They've even got undergrad degrees. There was a young man here in Kansas that actually went through their undergrad program at the same time he was finishing high school. So he graduated with his bachelor's degree from Harvard 2 weeks before he graduated with his high school um, degree, and that was here within 2 or 3 years ago. I think they've changed the rules because Harvard's like it makes us not look like we're very rigorous if we do that. So I don't know that you can do that today. But they're fairly, as far as top tier colleges, they're some of the extension school is one of the less expensive options. It's they've been around for over 100 years, offering like they do night classes and things like that. So they pull from their professors, have them teach their classes for people that are non-traditional students and stuff. They moved online in the early 2001 or something like that. Or moved a lot of their stuff online. They still have in-person classes too. Anyway, I've been very impressed with them. I got a master's degree through them. It was very, very good teaching, very good pedagogy, and it was very well worth it to me. I also was with an employer that was paying for most of it, which worked great as well. But anyway, that's something definitely to look at if you're looking for something more formal. University of British Columbia on edX. So Harvard would be if you're looking for a degree or if you're looking for uh, things that would actually count as college credit. University of British Columbia on edX, I think they have some way to get credit, but a lot of their stuff, they have they've got professors that have put them together. And let me back up. On the Harvard stuff, at least the way it was when I was there, you were watching videos of actual classrooms. You had a teaching fellow that was online that you could talk to. It was very much replicating the college experience of listen to a lecture and then do the homework assignments and stuff. University of British Columbia on edX is more of the model of we're putting courses online. And the two that I found to be really, really good, the how to code simple data and how to code complex data, we're going to look at those in just a second. Those are very, very good, but they've also got these MicroMasters that are like 4 or 5 courses on getting you started with a software development foundation. So the how to code simple data. So this over here, this Space Invaders, a game. I went through this course and then I had my son do it when he was, how old was he when he started? He may have been 11 or 12 when he started. But the final project was to make a Space Invaders game. And that was a screenshot from his game. Now, it's not one of those things where you're dragging pictures around to make them work. Like each of those little things you see there, he had to define the oval and then a clear oval on top. So everything was actually written as code for that whole thing. It wasn't a drag and drop environment. They use Racket for this, which is a lot of fun. It's a list-based programming language. But the goal of this is to get you to think about how to break problems down, how to decompose problems into something simple, solve the base case, and then if I can do that, kind of extrapolate for all the things that are in this list of stuff. So it's a very step-by-step way of learning how to break problems down, how to think about creating programs. I find it very, very good. It's like I said, I think he's exceptional, but my 11 and 12-year-old was able to do this. It's not something that's out of reach because the pedagogy is so good. They're very, very good at taking you step by step through things. And then the follow-on class to that is how to code with complex data. And in that one, you're doing things like creating a Sudoku solver. So like you give it a Sudoku puzzle and it solves it. So it's like a backtracking algorithm. Or a scheduling system where you say, we've got all these tutor slots we need to fill. And we've got all these tutors and they can only work so many times and they're only available on these certain days. Now give me a schedule that actually will work with what we have, or tell me there's not a possible schedule. And those are very interesting problems. Anyway, if you go through the whole thing, you get to that point and they're not It's not that they're not difficult to solve. We spend a lot of time on those, but it was doable. You had enough information to do it. So these are two classes that I highly recommend. They will not prepare you for just being a Java programmer. They're even in another programming language, but the programming language is selected to be very, very simple in order to let you, not simple and you can't do things with it, very simple to understand, so you can focus on the underlying problem solving techniques and get really, really good at that. This how to code, there's a whole kind of movement around that. It's Matthias, drawing a blank on his last name here. Anyway, there's a textbook called, let me see it, just how to design programs. It's over on the shelf over there. How to design programs. It's very, very good. It's free online. If anybody can't find it, want a link to it, let me know and I'll get you a link to it. But it's a very methodical way to think about how can we teach people to solve problems. And I highly recommend it. Okay, so those are two things. Those are on edX. Highly recommend those. This is another one thing that I went through, and I'll probably have my son go through it at some point. It's called Nan to Tetris. It's a course created by two professors at the Hebrew University in Jerusalem, I believe. And what this does is this teaches you how a processor works. You start out in a simulator on your computer with a NAND chip, and you build up an entire processor that lets you go ahead and run Tetris on it. So you're actually creating a processor from scratch, but in a simulator. There'd be way too much soldering to do what you try to do with it. Anyway, it's very, very good. If you go through this, you understand a whole lot more about what's going on behind the scenes on the computer, and it's extremely good pedagogy. They did a very, very good job of taking it to where you're coming in with maybe a little bit of experience with you got some math and you've got some little bit of understanding of logic, but they take you through it very step by step to where you can actually be successful with it. So anyway, that is a great thing to look at if you're particularly if you're a developer and you're like, I just like to know more about what's going on under the hood. This is a very fun way to do it. So I highly recommend that. Kind of in this idea of how to design programs, here's a couple books. And the colors don't look good at all on this, but The Little Schemer and The Seasoned Schemer, there's a whole series of books, these little books. And I meant to show a picture of what it looks like inside of it, but it gives you, there's two columns. It asks you a question, you cover up the other column and you answer, then you look and see if your answer matches what and it's a very, very interactive way of walking through things step by step. And I found these to be very, very useful. In fact, I'm actually going through one of the books right now. It's about machine learning that came out here a few years ago. And it's challenging me. But one thing I want to point out is it's not really even expected that you do this at a computer. This is a picture from when I was working through some of the things. It's done. The questions and things they're asking you, most of them are done in a very small way that you can actually do them on a piece of paper and reason through about them. If you want to get good at programming, trying to program on paper with a pen is a very, very good way of making sure you understand exactly what's going on and how you think through it. So these books are great for learning to think about how to solve problems in computation in general. These first two, Little Schemer and Seasoned Schemer. And then the Little Learner is the one that I'm going through about machine learning. So these can be great. And this follows, this is based on the same kind of methodology and philosophy of learning programming and computer science as the stuff at the University of British Columbia that I pointed to earlier. Okay, so other thing, let's say you're a developer and you're like, or you're learning a programming language and like, I just need more time to practice. Well, here are two great ways to do that. There's Project Euler. Euler was a mathematician, and Leet Code. So let me show you what these look like. So here's Leet Code. There's paid accounts. I've just used the free account, but you log in and it gives you things like, oops, did I not? Okay, there we go. Anyway, it gives you a bunch of problems. So here's the very first problem they give you, which is two sums. And it defines the problem. I'm going to take two numbers and an integer that I'm or two arrays of numbers, and then a target that I'm trying to get to. And I've got to find the two numbers in those array, the indexes of the two numbers in the array that will add up to that target. So this was one that I did a long time ago, and I was doing it in Racket or Scheme. And you type your program in there, and then you run it, and it validates it against the examples and then against a bunch of other tests and make sure that you actually were able to pass it. And it gives you some interesting things, statistics like how many people pass this on the first try. And it will also let you compare how long it took to run your program with others to see if you're being efficient and stuff. There's lots of things built around that, but you're actually typing it into their web page and it's running behind the scenes and then giving you feedback. Anyway, it's a lot of fun and it's a great way to just sit down and, I mean, if you keep doing this on a regular basis, you're going to be solving problems, getting really good. It's a great way to learn a new language. If you're like, I want to learn Python or something like that. And there's a bunch of languages to choose from. Project Euler is a little bit similar. It's I don't even think they have a paid one for them, but it's kind of similar in that you've got all these things you can choose from. But what's different about it is it doesn't actually expect you to run them on the website. It asks you a question like this, like we list all the natural numbers below 10 that are multiples 3, 5, and we get 3, 5, 6, 9. The sum of these multiples is 23. Okay, now do the same thing for all the numbers that are below 1,000, and then type in that number. So usually there's one answer at the end of it, and then it'll tell you if you're right or not. As you get into the more advanced problems, it starts asking things that if you don't code it, if you code it with a naive solution of just, I'm going to brute force this, it's very easy to get in a situation where your computer will just never finish. So it's got this kind of aspect to it of making sure that you're also being efficient in the way that you're answering it. And I actually have not used this one since they made some changes to it that track your progress and stuff. But I think it also gives you, there's ways to get in and see other people's answers and some things like that, and some things around that built around it like that for interacting with other people. So does LeetCode. But both of those are great ways if you're wanting to increase your programming skills. You've got a little bit of skills in programming, or you're trying to learn a new programming language. These can be great ways to go. Okay, well that covers the and if anybody else has something that they found to be useful, throw it in the chat so other people can see it. The other thing that I did not create any slides on that that also is interesting in learning development skills is there's been a push in a lot of areas to kind of switch to doing more robotics-based things than dealing with just writing programs that do things on the screen. The reason for it is there's a couple of reasons for it. One reason is because it's a lot more fun to play with robots. Middlesex University, their first 2 years in computer science program is based around these Murdo robots, and I built one based on kind of their specs and played around with it. But it lets you work at things at many different layers. Like you can program in Java, you can program in Racket or Python, or you can get really, really low level and do things with the Arduino level stuff of directly looking at all your sensors and things. So that's something to look at too if you're looking at wanting to develop either your skills or get into software development, or especially if you've got a kid that's interested in doing something, looking for good ways to learn how to program using robotics. And if that sounds interesting, you can't find something, reach out to me. I'll send you some links to some things that I thought were useful. Let's see. There was something else I was going to say about the robotics, but I don't remember what it was now. Okay, so kind of as a wrap up, I want to mention I did this class here a while back. This is a paid class to improve your Agile skills with 5 business books, and we went through every week. We took another business book, we watched a summary of it, and then we really talked about how that applied to us in our particular situation. It was a lot of fun. I learned a lot from it. People said they learned a lot from it. We've got some testimonials here. Anyway, you'll get an email about this later once I get it set up and scheduled, but I wanted to throw something out here. I like to start these with a few people actually set up, scheduled for it. If this sounds interesting, send me an email and I'll put you on my short list of people that I give the biggest discount to for just a short window, if it sounds like it's interesting to you, to kind of, we do this on Maven, and if I have a few people in it to start with, it helps promote it for other people. So if that sounds interesting, send me an email. I will make sure that you get on that short list for that window where we've got the ultra early bird pricing. Okay, so that covers what I was wanting to cover today, and we're right about time. I am going to stick around for a few minutes, though. If anybody has any questions about this or anything else, I see we've got some links here to some programs, and that looks great. There's some really cool things out here, and I'm going to go through and look at that. Oh, I'm pronouncing the name wrong. Okay, it's Euler. That's right. I messed that up before, and I continue to mess it up again. So thank you for correcting me on that. So I'm going to stop my streaming here if I can figure out how, and love to chat with anyone.